Hello, good morning all. I am Dr. Raj Mohammed, working as Associate Professor in the Department of CSE, Kalaignar Karnataka Institute of Technology, Coimbatore. So today we get into the next aspect of lexical analyzer, that is Lex, Flux, YACC and Bison tools, and that helps us in automating the lexical and syntax analyzer process. So let's straight away get into the generation tools and their types. So Lex, Flux, YACC and Bison. So we know that Lex leads to lexical analysis, Flux first lexical analysis, YACC yet another compiler to compiler, and then Bison. So these are the open source tools which are available and that can be used by us to process lexical as well as syntax analysis. Now, why the compiler generation tools are required? First thing, it is extremely complex for manual construction of lexers and parser. See, we cannot directly go as a human being, go and do the process of lexing and lexemizing and parsing each and every component of a program. So in that case, we wanted to automate. So we look for certain tools which are available or ready to be used for lexical and syntax analysis. So those tools will help us in automating lexical and syntax analysis. Now, by automating them, we are trying to reduce the errors and also the development time involved in developing code. And it is also widely used in real world compilers like C or C++. Say for example, if you take the case of a C, we have different flavors like ANSI C or Microsoft C or IBM C or Borland C, and then GCC based on the Xino or the Unix platforms. So we have overview of those tools. Lex and Flux. Lex refers to the lexical analysis. Flux refers to the fast lexical analyzer tool. YACC, you know that yet another compiler to compiler. Bison is a big tool that is available as a single bundle to do the process of syntax analysis. And when these things are used together, we'll be able to develop a front-end compiler. The front-end compiler means what? Source code, when a source code is fed into the compiler, and it will be doing the process of lexical analysis, either recognizing the keywords and then passing those keywords into the syntax analyzer to generate a syntax tree. And that syntax tree can be simplified and then can be evaluated using any of the modern day tools, so that now we can get we can derive the expected result out of it. And then let's get into the Lex tool first. Lexical analyzer generator. It's developed by IBM's Bell Laboratories, and what it does is that it takes the regular expressions as input. We know that regular expressions are the ones, shorthand notations which are used in finite automata or deterministic automata, which is divided into deterministic, non-deterministic kind of stuff. So in a regular expression is taken as a input of the lexical tool is used as a reference to recognize the keywords, identifiers or any other stuff to be recognized. Then generates a corresponding C code for the lexical analyzer. That means a downsized code that could be easily understood by the machine. Next comes the Flux tool, which is a fast lexical analyzer generator. So it is also an open source replacement for Lex, and this can be done, or this is widely used in Windows platform, and then it has a built-in IDE, and here with this Flux tool we can also have a integrated development environment IDE, that is a visualized environment where we can work with with ease rather than working in a command prompt. So this Flux tool offers both flavors of Windows based as well as command based, and it helps in fastening up the process and more flexible to us. It produces a file called lex.yy.c once we go for the lexical analysis. any programs like C or C++ can be done, can be compiled, or rather lexically analyzed using this flux tool. And then the comparison, or the how the lex and flux work. Input of lex and flux will be a source program, and the source program which is converted into tokens. Now the tokens will be having rules. Those rules are actually referred or described in the form of regular expressions. What would be the output of this lex or flux? That a corresponding C program implementing the function called YYLex, which is a built-in function. It simplifies the tokens and then produces the C program format, which can be easily understood by the compiler. And then during the process of recognizing, converting or generating the output, what it does is that recognizes the tokens and then returns them to the parser. So, for example, if I am having a variable called int a, b, c, and a, b, c were the three variables declared, and those a, b, c will be recognized as identifiers. Then comes the YACC tool, yet another compiler to compiler tool, which is again an open source one. What it does is that it generates a LA-LR parser. We know that LA refers to look ahead. By one symbol ahead. That means, for example, if I am currently processing one particular variable in a string, and LALR parser will look for the next upcoming character also. So that means one character ahead. That's why it's called as look ahead, left to right parsing, LALR parser. So here the input will be a context-free grammar. We know that a context-free grammar will be having variables, terminals, productions, and a starting symbol, and using which we can generate a syntax tree. And the output of this YACC tool would be y.tableized.c, tab.c, which is a parsed code or a parser code. Rather, we slightly call it as tab file. And then the Bison tool, which is also a GNU recognized one, open source tool, or otherwise it could be used as an alternative to the YACC. Say the Bison tool is the one that is actually integrated with the flux, that is clearly mentioned there as commonly used with flux. What it does is that apart from optimizing, it improves error handling, better diagnostics, like recognizing the types of errors, and then providing suggestions how those errors can be fulfilled or can be fixed. And then it also has certain extensions like program specific extensions or language specific extensions, like I can exclusively work for Java or otherwise a C or a C++ kind of programming stuff. So widely or commonly used with flux. And then YACC and Bison working together, where the input will be a grammar come semantic actions. So grammar, in the sense, grammar will not be written as a text, rather it will be given as a syntax tree or a regular expression. So the grammar along with the semantic actions, like whether plus operator is an arithmetic operator, or are you going to add two literals or going to add two strings, kind of explanation will be available with semantic actions. Output would be parsed. That means that will be actually called by YYParse function, which is available inside the YACC. What it does is that it interacts with the lexer via the tokens. That means tokens are recognized and then they are processed through Bison. Then the combinations of lex, flux, YACC, Bison pipeline is that very simple, that we start with a source program, C or C++ or Java or any programming language, and we use lex or flux to generate the lexers or lexems, and then we either use YACC or Bison to do the process of parsing, and then after parsing we will be getting the syntax tree or the intermediate form, rather the grammar with the semantic form, and leading to next set of intermediate code generation process. So you consider this one as a real life analogy. So in terms of language translation, first of all, when we speak something, words need to be identified. That is nothing but lexical analysis, which is correspondingly implemented by lex and flux. Then the sentence structure checked. Now when we say he is coming, we need to know whether the word he is coming is properly aligned or properly structured. So syntax analysis is done by YACC and Bison tools. And then when I say that he is coming, whether the statement is or sentence is having meaningful meaning, and that is done by semantic analysis, meaning construction, or processing it into the next level or the further level. So likewise, any spoken words or any typed words can be analyzed. Say for example, when we try to convert from one language to another language. So like learning a grammar before writing an essay. So here is the summary for today's session, that we have to check with Lex or Flux. So Flux is the faster one and the modern one and ready to use. Whereas the Lex provides only command prompt, Flux provides the graphical interface. YACC and Bison, YACC is an old version with command prompt, whereas Bison is GUI enhanced, and that can be used with any kind of platform. And then the industry preference for processing such things is Flux in tandem with Bison or alongside Bison. Thank you. Now what is the advantage of having all these tools? First of all, as I said earlier, that automation of compiler front end. Everything is automated. The lexical and syntax analysis both are automated. Easy modification of rules, when I'm having some rules to be changed, I can go with grammar or the regular expression that can be easily modified, and then reducing the development errors in terms of reducing simple mistakes or type mistakes, type mistakes committed by users. And then Lex, Flux, YACC, Bison, they are all having widely supported and well documented help segment, so that we can avoid errors while using these tools. And where actually we use these? So compiler interpreter design is not a joke. It is working again a domain specific language. If I'm using C, it will have its own C compiler, or similarly C++ or Java or like that. So compilers are language specific, and still we are in a world where we are trying to develop a compiler which can take up any sort of language and then produce it. Then literally it processes the tools our source program along with the data provided for processing, and then configuring and scripting of languages modern day React, Node.js and Express and all fall into the category of scripting languages, also get to be interpreted. Now comes the final summary segment, where Flex and Flux for tokenization, YACC and Bison for syntax analysis, and then these two together forms the front end of the compiler. And this is the first front end comes with lexical and syntax analysis. Part of the intermediate code is done there, forms the first or the initial segment of compilers. Thank you all.